Alright, finally found the time to do a few more solutions. So let's have a go. This is May 2015, Paper 1, Time Zone 2, and we're up to question 9. Nearly there. Alright, let P and Q have coordinates 1, 0, 2 and negative 11, 8 and M respectively. Express PQ in terms of M. So this one's obviously not going to be too bad for us to start with. Oh look, I've even got a pen chosen. So what's PQ going to be? So PQ is just the coordinates of Q minus the coordinates of P. So corresponding coordinates, so we've got negative 11, take away 1, we have 8 minus 0, and we have M minus 2. And what does that simplify to? Negative 12, 8, and M minus 2. You'll always get a nice easy one with these ones. So there's 2 marks that you can just lock away. Not too bad. Let's keep going. A and B are perpendicular vectors, where A is 1, 1, n, and B is negative 3, 2, and 1. Find n. So what do we know about perpendicular vectors? We should know that perpendicular vectors have a dot product equal to 0. So if I go A dot B, I know the answer is 0. How do I get A dot B? It's multiply the corresponding coordinate. So it's 1 multiplied by negative 3. That looks a bit funny. I think I was going to do an equal sign, then forgot what I was doing. So there's the corresponding x coordinates for each one, plus 1 by 2, plus n times 1. And together that equals 0. So that's why I was going to do an equivalent sign there. I'll get the hang of this again. Maybe. There we go. Alright, so we've got negative 3 plus 2 is negative 1, so n minus 1 equals 0. N is equal to 1. Got your next one done. Given that PQ is parallel to B, express PQ in terms of B. So PQ, if it's parallel, it's going to have the same component. So you can see here, now B is negative 3, so that needs to be multiplied by 4 to end up at negative 12. Similarly, 2 needs to be multiplied by 4 to get to 8. So obviously PQ, we can assume, is 4 times B. Finally, we've got find M. So that's C part 1. C part 2. So there we had, because it was a multiple of it, we could see that the multiple was 4. So now we know that 4 times, so M minus 2 must be equal to 4 times the corresponding component in B. So you can see there the final component of PQ, M minus 2, has to be 4 times B, which is 4. For the corresponding component of 1, and then I add 2 to each side. And I found M equals 6. Flying through it, there's, 5, 9, 11 marks. It's only taken us 3.5 minutes, so you've got plenty of time left. Although I haven't done the last little bit here. In part D, the distance is meters and the time is in seconds. Let's do it. Particle moves along a straight line through Q, so that its position is given by R equals C plus T times A. Write down a possible vector C. So what are the possible vectors for C? Well, the easiest thing to see is that if it's going through Q, and if we have a look up the top there, we've got Q, negative 11, 8, and M. So for me, by far the easiest option for D is just to say vector C, I'm going to let it be that point Q, negative 11, 8, and M we figured out before was, let's scroll up a little bit there, where do we find it? Oh, just above there, M equals 6, that's it. Oh, now I've lost where the cursor is. Let's find that back. There we go. 6, there we go. Get a bit confused there. Right, finally find the speed of the particle. So we know the time is in seconds. Now, with a vector equation that we've got here, R equals C is just locating 1 point, and T is the time in seconds, we're given that, and it's multiplying by a. So if we knew the magnitude of a, that's how many meters it would be moving each second. So we're going to go ahead now and work that out. So we've got vector a, we need the magnitude of it, so we can work out how fast this particle is going, and it was 1, 1, and n. Remember your special case of Pythagoras' theorem in 3 dimensions is actually really straightforward, and n was 1 as well there, so we've got 1 squared plus 1 squared plus 1 squared, all square rooted. So a is root 3, therefore the speed is root 3 meters per second. And we're all done. One question to go in this paper, and then we'll move on to the calculator papers. See you then, guys. Cheers.